Students, we are going to learn how to integrate integral 0 to infinity 1 over 1 positive x raised to the power 2021 times 1 positive x squared times dx. Now, to obtain the solution for this, we need to make the following substitution. Let u be equal to 1 over x. Now, this means x is equal to 1 over u, and differentiating we get, and dx would be equal to negative 1 over u squared times du. So we would be using the following substitution. So this is equal to integral, I'm not touching the limits. So in place of dx, I would be substituting du divided by u squared with the negative sign. And in place of x, it's going to be 1 over u. So I place 1 over u, that has to be raised to the power of 2021, close the parenthesis. Similarly, for x, it's going to be 1 over u, that has to be raised to the power of 2. Now, rewriting this as negative integral du divided by 1 positive 1 over u raised to the power 2021 times 1 positive 1 over u squared times, I place this u squared there. Now I can simplify this and rewrite it as taking the LCM as u raised to the power 2021. That would give me u raised to the power 2021 followed by a positive 1. This is for the denominator. Of course, in the numerator you got du. Similarly, taking the LCM as u squared, I would have u squared positive 1, placing this u squared there. Now clearly the u squareds can be cancelled. Now this can be flipped and taken to the numerator, and when I do that, I would have negative u raised to the power 2021 divided by, I'm rewriting it as 1 positive u raised to the power 2021 times 1 positive u squared. Of course, I need to place du in the numerator. So I've got something like this. Now I have not touched anything with the limits. Now let us change the limits. Now when x is equal to 0, the limits are actually 0 to infinity. When x is equal to 0, what happens? U will be equal to 1 over 0. So this would mean u would be approaching infinity when x is approaching 0. So the lower limit will be infinity. And also when x is equal to infinity, u will be equal to 1 over infinity, which means u will be approaching 0 when x approaches infinity. So the limits would be infinity to 0, infinity to 0. Now I've got infinity to 0 with a negative sign. Now we know that from the formulae or from the concept of integration, if I were to flip the limits, the sign would get changed. So when I do that, I would get 0 to infinity and the negative sign would be lost, giving me integral 0 to infinity u raised to the power 2021 divided by 1 positive u raised to the power 2021 times 1 positive u squared times du. Now since the variables are u, if I were to change them to x, then the integration would become 0 to infinity x raised to the power 2021 divided by 1 positive x raised to the power 2021 times 1 positive x squared times dx. Because u is any arbitrary variable, so it doesn't matter if we are going to have here as u and I change it to x, or if I am changing it to p, it doesn't matter. Now on the left, we started with this integration, integral 0 to infinity dx over 1 positive x over 2021 times 1 positive x squared. Now the reason I changed it to x because the given integral is in terms of x. Now our purpose or objective is to solve for this integral and obtain the value or the answer for this integral. Now what I'm going to do is I'm going to be dividing x raised to the power 2021 by 1 positive x raised to the power 2021. Now when I do that, I would get 1 here, and that's going to be x raised to the power 2021 followed by a positive 1. I subtract, I get a negative 1 as the remainder. Okay, so I am going to be rewriting x raised to the power 2021 divided by 1 positive x raised to the power 2021 as the quotient is 1 followed by the remainder negative 1 over 1 positive x over 2021. Now why do I do that? You will see that because of this representation the solution becomes easy to obtain. So in place of this x raised to the power 2021 divided by 1 positive x raised to the power 2021, I would be using 1 negative 1 over 1 positive x raised to the power 2021. So when I do that substitution, I would now have integral 0 to infinity 1 negative 1 over 1 positive x raised to the power 2021 times 1 over 1 positive x squared times dx. Now this can be rewritten as integral 0 to infinity. I'm going to multiply 1 with 1 over 1 positive x squared. So that is going to give me dx over 1 positive x squared, negative sign, negative 0 to infinity. Multiplying these two quantities would give me dx divided by 1 positive x over 2021 times 1 positive x squared. Now on the left I have integral 0 to infinity dx over 1 positive x over 2021 times 1 positive x squared. I've got this. Now what I'm going to do is I'm going to move this negative sign to the left. That would give me integral 0 to infinity dx divided by 1 positive x over 2021 times 1 positive x squared, positive integral 0 to infinity dx divided by 1 positive x over 2021 times 1 positive x squared is equal to integral 0 to infinity dx divided by 1 positive x squared. Now you can add these two together, and when I do that I would get 2 times integral 0 to infinity dx over 1 positive x over 2021 times 1 positive x squared is equal to, now when you integrate integral dx over 1 positive x squared, this is going to be tan inverse of x. The limits are 0 to infinity. Now if you apply the limits for the first quantity, it's going to be tan inverse of infinity. Second quantity is going to be negative tan inverse of 0. Now tan inverse of infinity is pi over 2. Tan inverse of 0 will be 0, so no need to place it. And therefore the left side, integral 0 to infinity dx divided by 1 positive x over 2021 times 1 positive x squared is now, I'm going to bring this 2 down. So when I do that, I will have a 1 over 2, that's going to be pi over 4. Now this is the final solution for this question.